Today we're going to be proving that a quadrilateral is a parallelogram. So pretty much what we're doing is we're flip-flopping what we did yesterday. So we're taking the converse of all those theorems. So our first theorem says that if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So the key thing here is you have to be given both pairs of opposite sides or it can't be a parallelogram. So here we have AB is congruent to CD and AC is congruent to BD. So we can then say we have a parallelogram. Our next theorem says that if an angle is a quadrilateral, it's consecutive angles, then the quadrilateral is a parallelogram. So again, it has to be both of them. So if we're looking here, angle A has to be supplementary to angle B and angle C in order for us to have a parallelogram. The next theorem says that if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So again, we have to have both pairs in order for this to be a parallelogram. So A has to be congruent to D and angle C has to be congruent to angle B. If we just had angle A congruent to angle D, but not B and C congruent, then we cannot say it's a parallelogram. And the next one is if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So when we have the bisecting, that means they cut each other in half. So that would be AE is congruent to DE and CE is congruent to BE. Again, you need both of those things to be true in order to have a parallelogram. And this one is new. So this one says that if you have one pair of opposite sides of a quadrilateral, that is both congruent and parallel. So this is the key statement here, congruent and parallel. Then you have a parallelogram. So if we look here, side AB is congruent to side CD, and it's also parallel. We know it's parallel because of those arrows. Then we can say that we have a parallelogram. So some example problems here. We're going to have to find x so that ABCD must be a parallelogram. And so what we first have to think of is look at the picture and figure out what kind of angles do we have. If we look here, 5x and 120, those are opposite angles. And we know that if we have a parallelogram, in order for it to be a parallelogram, the opposite angles have to be congruent. So that means that their angle measures have to be equal. So I'm going to set 5x equal to 120. And then I'm going to divide both sides by 5. And that gives me x equals 24. So if x is 24, then it is a parallelogram. Now looking at number 2, I look at the two angles where they've given me information, and those are consecutive angles. Now in order for this shape to be a parallelogram, the consecutive angles have to be supplementary, which means they have to equal 180 degrees. So I'm going to add them together and set them equal to 180. Then I'm going to combine like terms on the left-hand side. Subtract 18 from both sides. And then divide by 9. And that gives me x equals 18 as my final answer. Our next problem, we're given the diagonals. Now, what do I know about the diagonals is that they have to bisect each other if it's a parallelogram, which means that they have to cut each other in half, meaning that those halves are equal. So I'm going to set 2x plus 6 equal to 4x minus 8 and solve for x. So I'm going to subtract 2x from both sides. So I get 6 equals 2x minus 8, and then I'm going to add 8, and then divide both sides by 2, so I get x equals 7. Now this one here, I don't have both sides, so I can't say that the parallelogram is parallel because of both sides being congruent for number 4. But I can go the route for that new theorem where we have one side congruent and then we have parallel sides. So if we look here at these angles, we've got these two angles. Those are alternate interior angles. So that would make these two lines parallel. So now what I have to prove is that the sides are congruent. So I'm going to figure out what x would be to make the sides congruent, and I am going to change this problem a little bit to a plus 12. And then I'm going to go ahead and solve. So again, in order for them to be congruent, that means they're equal to each other. So I'm going to subtract 10 from each side. And then I'm going to add 8 to each side. And then lastly, I'm going to divide by 5, so that will give me x equals 4. So now I can say that this is a parallelogram if x equals 4 because I'd have the congruent sides, one pair. Then I'd also have the parallel lines.